Hi, my name is Sharon McCoy, and I teach biology and chemistry at Conant High School in Hoffman Estates. I'm one of the authors on the Biosensors Module, and I'd like to take some time to go through a few of the activities that you're going to encounter in this module. The first activity, the students get a pretty good understanding of bioluminescence and biomolecules by using whole fireflies. They actually use 3 different samples of fireflies. They use the whole tail lantern, they use the whole firefly, and they also use a lantern that's been crushed. And they mix it with a buffer solution and an ATP solution to see which one of those samples lights up. Once they determine which of the samples light up, they then go about testing those in different temperatures. They put their samples into a cold ice water bath to see what happens to the intensity of the color. Then they put them into a hot water bath to see what happens to that light as well. And in the hot water bath, since the enzyme is broken down, they can see that they can then enter into a discussion about enzymes and what types of conditions are going to be favorable for enzymes to work. In the second activity, they look at 4 different types of indicator molecules that they're going to use later in the module, and they look at what type of signal those different indicator molecules produce to determine if a substance is present or not. In the third activity, the students actually make a peroxide biosensor. They use peroxide and they use an enzyme called peroxidase, and they try to determine what the detection limit is of this biosensor. Students begin by putting peroxide into a test tube cap, putting peroxidase into the test tube cap, and then using a sensor strip that has one of the indicator molecules that they tested in the second activity and putting that into the test tube cap as well. And what they're going to find is that the color on the strip is going to change. It's going to turn purple, and the darker the color, the higher the concentration of peroxide. Once they determine what the signal is that they're going to be looking for, then they can move on to Part B. And in Part B, they have a chance to choose 8 different concentrations of peroxide. They set up the same situation, different test tube caps with the sensor strips. And after they get the results, what they'll see on the sensor strips, they'll see a different intensity of color as well as a different height of the color on the strip. And from that, they can quantify that by measuring the height of the color on the strip. They can then graph that, and they can determine what the detection range is of that particular biosensor. In the final part, they're given 2 unknown solutions. They don't know what the concentrations are, and using their graph and using the biosensor, they're able to determine what the concentration of those 2 unknown solutions is. In the third activity, the students used a 1-enzyme biosensor, and in the fourth activity, they get to have an opportunity to use a 2-enzyme biosensor, a cholesterol biosensor. And in the first part of the activity, they test different concentrations of cholesterol to determine what level the biosensor can detect. And in Part B of the activity, they're given 5 patient samples, and they test the level of cholesterol in each one of the patient samples. Once they get the results, they then have to communicate the results to a doctor and let the doctor know whether the cholesterol level is too high, too low, or within the acceptable range for cholesterol. And the fifth activity also deals with cholesterol, and the students have an opportunity to take a look at a home-use cholesterol kit. They are able to look at how the biosensor works as well as some of the desirable features of this particular kit. The design project for this Biosensors module gives the students an opportunity to build a glucose biosensor. And this biosensor is actually a 3-enzyme system. The students are given all the pieces to put the sensor together, and they just need to decide what order they need to put these things together in order to have the biosensor detect whether glucose is present or not. The Biosensors module gives a great opportunity as an introduction to students of enzymes, catalysts, and biological molecules. The activities are interesting, thought-provoking, and engaging. The module also demonstrates how biosensors and biological molecules can be detected in living systems.